Hello everyone. If you are familiar with the Arduino programming and some TFT screens or graphics functions, then there's also a good chance you are familiar with the Adafruit GFX button class. It's a very practical class. It allows you to draw buttons on the screens. However, it is pretty constrained and it only allows you to draw the predefined color scheme with the string of characters in it. However, Adafruit has left many drawing functions in its library ready for use. So I thought I'm gonna extend the button functionality, and I wrote the custom button class that allows you to work with bitmaps and masks and draw them as the button itself. The class keeps it coherent with the original Adafruit GFX button naming scheme, so using it is in many ways seamless to the original Adafruit GFX button. However, for such a class to make sense, it was also necessary to write a tool available of exporting arrays of bitmaps and masks from the usual BMP format. This video will be a deeper dive into the tutorial example presenting custom button class next to the original Adafruit GFX button. It will start by presenting functions from Adafruit library that made it all possible. Then it will explain the example included with GitHub files showing the operation of the class. It will continue into the included with the GitHub files mask generator and bitmap generator tool. And it will finish by showing you the real world nice looking example of the menu on the 2.8-inch TFT screen. Hope you will find it as practical as I am. And let's just jump into the CPP. So this is the Adafruit GFX CPP file from the Adafruit library. And as you can see, Adafruit has left here many functions to draw bitmaps in many different ways. So for example, here's the function to draw 1-bit image at specified XY location with the defined 16-bit color in the 565 RGB format. So what it really does, it uses the mask of uint8t from the flash memory, and it uses this mask to determine whether pixels should be transparent or they should be drawn with the color that you defined in here. So this is one of the functions that this custom button class works with. You don't actually need to know this to use this class. I'm just saying for your knowledge. And there is more. So this function uses the 16-bit array of image, also from the flash memory. So basically, this is the pointer that you are sending to this function, and it's in the format 565 RGB. So I will show you later how to generate them. So here is how those pointers looks like and those masks. So this is the const uint16t progmem pointer. So this array will be basically recorded to flash. And here's the mask to this array. I will tell you later what are the possible options of displaying in this class. Inside the folder custom button example, there is example that I'm going to show you just right now. And it compares the Adafruit GFX button original class to this custom button class line by line. So first I include the MCU friend because this is driver library for the screen. Then I include this custom button class. Just remember to copy it, to copy the folder to the libraries folder in the Arduino library. And you just create the object of the TFT screen. You add a few more libraries for touchscreen and the font. you define minimum maximum pressure for pressing on the screen. Then there's define of the few colors. Those are coming from the calibration of the screen. So if you have already running screen, you should have this ready. And there is the touch get XY function that writes to cursor pressed and to cursor XY the position of the cursors. Okay, so usually you start Adafruit GFX button somewhere in the global space. The same you can do with the custom button. And then I define also in the global space those arrays of bitmaps or masks. So one are 8-bit, others are 16-bit. And then in the setup, you will see start up your screen. And normally you would init the button, writing something like this. Screen object, position and size of the button, then color scheme of the button and the string, text string of the button and the font size. So for comparison, you can init custom buttons on at least a few different ways. And depending how you write this init button function, they will later be displayed in using different functions from the Adafruit GFX library. So for example, here there is the place on the screen. Here's the which and the high, which has to match the arrays. And here's the for mask. So this is the mask of 32 times 40 that was previously generated. And this is button working with the green mask and the pink mask. This is the original Adafruit GFX button from this example. Here it is, and yeah, that's how it works. And the second one with the mask defined with green and pink colors. So the bitmap used to generate the mask looks like this. And then you run it through the tool, and the array you get in here is what you are using with the init button of the custom button class. And notice there is green and pink, so this is the green scheme. And when you press the button, it will turn into pink. It is actually refreshing so fast that you can't see it good, because it's just printing pink and then green back again, the same as the previous one. But if you're gonna use it realistically before doing some operations and after it, then it will look normally. And the third way of displaying it is with using the, for example, array of the RGB in 565 format for the let's say true and false color, like with the original Adafruit GFX button class. So here's one array, here's second array, and here is the mask. So that's it. This is it. And again, X, Y, which high. Remember that the bitmap has to be the same size. So here are the RGB 565 bitmaps for true, for false. Here is the mask, and I'm using the same mask for both true and false. So here's how the button works. It is relatively slow. I actually should have used here two nulls. Notice here and here there are nulls, so I'm going to comment it. So now this is version with the two nulls. What it really does, it changes the execution scheme of the draw function. It uses different function to draw, and the rest of the usage is basically seamless to the original Adafruit GFX button function. So you can draw buttons exactly the same. You can check for the position if it was pressed or not, exactly the same. Let's jump into the code of the class itself. So those few init buttons are working this way, that if you call one of them, then from this point on the draw calls will be using different drawing scheme, different functions for the drawing schemes. So here is the drawing scheme, draw button function. This function draws the button, and depending on the init button function area, it can draw the button using different functions that I showed you earlier from the Adafruit GFX CPP. So it draws this mask thing with the defined colors, or it uses the RGB 565 bitmaps with the mask or without the mask, depending on how you use the init button functions. Okay, so let me dive a bit into those press functions and the usual way how you determine whether the button was pressed or just released or whatever is happening with this button. The usual method that was presented by the Adafruit works this way, that on every frame, independently whether the cursor was pressed or not on this frame, you just call this press function on every button, and you check also this function if the cursor was contained inside the button. So this looks like this. The press function saves the current state to those two variables, current state and last state. And obviously, as you can see, shuffles them. And then the just pressed and just released functions determine whether the button was pressed or not based on those two variables. So let me visualize this on the table. Here are the not pressed times of the button, pressed times of the button, not pressed, and multiple press again. They are all multiple because it symbolizes the realistic usage of the screen. So when you think you are just pressing it fast and releasing it, this is happening during the multiple frames. On the bottom there is current state and last state variable, and there are those two functions, just pressed and just released. So here the table is filled, and you can see that just pressed and just released, they only return the positive values on when the state of the button is changed. So if you would stop refreshing those functions that I showed you earlier during the times that there is no press of the button, then those just pressed and just released functions would always give you the negative value, because there wouldn't be a change of the state as long as the class is a word actually. So usually after you do this update on every frame with the press and contains function, then you can check on all the buttons you have run the update. You can use the just pressed function, just release function to determine what to do during this frame of the button. And if something is positive, you usually draw the button differently, and you can do something here, whatever the button was responsible in the menu of doing. So this is one approach, but there is another approach which doesn't require you to do those checks with every frame. If the cursor was not pressed, you just simply skip those checks. And it's a timing approach. Here it is. So let's just comment, for example, those two. And instead of those two, let's check if the cursor was pressed. So this is different approach. And notice that if the cursor was not pressed, you don't have to check all those things. So this last time used minis variable is added to the custom button class. So this remembers always the time when the button was drawn last time. And if you compare to this variable to the minis class of the Arduino library, then this will give you positive or negative whether you should again use the button or not. So this approach works this way, that if the user keeps holding on the button, you will get positive from this every 200 milliseconds. And if he stops pressing on the button, then you will get all the time negative. So this is added extra. And the second extra thing is this change position function. So if you would like to change the position where the button should be, for example, if you are making menu and the menu has to adjust to some type of data that is being displayed on the screen, and you need to recalculate the position of the buttons, then it's a very practical function to use without making this long call here to the init button functions. Okay, so it's time to show you the tool for extracting the images. It is inside the folder BMP extractor, and I'm releasing basically only the CPP file. I'm not releasing exe or object files. It can be compiled on an x86 machine, or basically whatever supports the fstream, eostream strings. Yeah, so basically almost any normal PC. So the extractor works this way, that it's just 120 lines of code. You just run it, and in the folder that you will run the BMP extractor, you should have all the input files in the RGB 24 or 8 for red, 8 for green, 8 for blue format. No alpha channel. And they should be named from input 0, 1, 2, 3, 4, 5 up to input 99. And the BMP extractor here will just convert all those files into the arrays. So first it will ask you for the type of the background used for the mask. So if the pixels will be white, which means 255, 255, 255 in RGB 24 format, then those pixels would be generated as the transparent ones. If you press white here and if you press black here, you need pixels 0, 0, 0 to be generated as the transparent. Rest will be generated as the um, actual color. So let's write B, because the input files are black in the background. Here are some examples. And you just press enter and finished. Sometimes it will ask you about width and height, but just overall speaking, follow the instructions. And you got the result in the file bmparrays.h. So here are the arrays, and it is that simple. So one thing right now is that you should have width in the multiple of 8. I'm not sure why it works. I checked both the algorithm inside the Adafruit, and this algorithm here should in theory work with other number of pixels in which, but yeah, that's the one thing that doesn't work right now. And overall speaking about the algorithm, it just reads those input files, and it automatically reads the width and height from the headers. So you can have different widths and heights in those input files. And if you want to mess out with the algorithm determining the mask, for example, then here in the for loop, you have those three 16 bits, 16-bit 1, 2, and 3, responsible for 3 different colors. And the final one that will be going into the bitmap into the BMP arrays file, bitmap like this, is actually the 16-bit. So they are just simply grouped together. If you want to mess with them, change some algorithm here. And if it goes to the mask is determined in here, current mask. So if you would just write in this spot here, change the current mask to whatever you really want, add this pixel, then this will be the mask just simply overwritten to whatever you want. There's some test images if you like to use. So those here to mask extraction as monochromes are good ideas for the buttons in the only mask format. You can tweak them probably because I just generated them fast, but overall they look not that bad, so they should work. There are also test images free, different arrows, OKs, returns, color version of the buttons, and there are another set of images, some save button for example, edit, and other stuff like this. All were generated in Blender, and then I tweaked them in the paint. This image in here is a test image to check the colors on the screen. You can use the directly Adafruit functions to draw this or the button also. And those are other test images for the colors. So here's the practical example what you can write using this class. All those buttons that I'm pressing are from this class. And save button also, I just don't want to save. So that's how it looks.